Hi everyone, my name is Jagan. Today we are going to learn about LVM method. LVM method is it is one of the methods it is one of the methods by using the LVM method we do the disk partition. In a previous class we have discussed about the basic method like how to do a partition using a basic method. Today we will learn the LVM method. The partitioning the LVM method is has many advantages over basic method. Generally, basic method has certain limitations as compared to the LVM. LVM is latest concept or latest I would say this is a thing that used to do a partitions in a disk. Okay. LVM. LVM stands for Logical Volume Manager. So LVM stands for Logical Volume Manager. So using this method, we do a partition inside the disk. Okay. So we'll see what are the advantages of partition by using the LVM method. Okay. So main advantages of LVM method. So main advantages of LVM method is the first one is disk extending the disk or resizing or reducing the disk size. Okay, see generally what happened is we have a for example disk is full. Okay, we want to extend the disk. So to extend the disk, so we can't do it in with a basic method. Okay, so to extend the disk, to reduce the disk, we can use the LVM method. So disk extending or disk reducing, disk extending and reducing. I would say this is a disk resize. So this is one of the methods. Okay, so extending the disk or reducing the disk depends on the requirement. So this can be done only with a LVM. Okay. The next one is it supports a RAID. Okay. RAID. Okay. LVM backs a RAID or supports RAID. See, RAID is one of the RAID is a backup technology. Now we use this RAID to back up the data. Okay, or to have any redundancy. For example, if one disk failed, so if one disk failed, then we still have a one more disk to have a connectivity. So we don't need to we don't have to face the a connectivity disruption. So to have a remain connectivity, the RAID is used. So LVM supports the RAID. In basic method, RAID is not supported. Okay. The next one is the partition. So in basic method, how many partitions can be done? Around 64 partitions, right? But here 29,932 partitions 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 are done. Okay. So in single disk, okay, 29,932 partitions can be done. That is the advantages of one of the advantages of LVM method. Next one is partition backup. So partition backup is one more advantages of LVM. So here disk extending and reducing is impossible, and LVM supports RAID impossible, and 29,932 partitions. Here only 64 partitions. Okay, and partition backup, no. So this is the basic method. This is the basic method. This is the LVM method. Okay. Now if you see, okay, so if you see the architecture of LVM, excuse me, generally what happened is when the disk is added to the virtual machine, it is the, we would say this disk is a raw disk. Okay, so the raw disk is converted to physical volume, and the physical volume again, sum of physical volumes made as a volume group. From the volume group we create the partitions. The Okay, so LVM architecture. So so the first step is disk is added to the VM. Okay, once the disk is added to the VM, disk is disk is added to the VM. The disk is nothing but raw disk or LUN. See, so once the disk is added, this disk is once the disk is added, okay, that is the LUN. The disk is added to the VM. That disk is we called as a raw disk. Okay, so the disk is converted to physical volume. Okay, generally we call it as a PV. Again, this sum of the physical volume will make it as a volume group. We volume group, and from the volume group we create the partitions. Partition is nothing but logical volumes. So here see, if you see the architecture, so from the raw disk, when the disk is added to the virtual machine, this disk is we call it as a raw disk. Okay, so this disk is converted to the physical volume. Okay, after converting the physical volume, then we convert it into volume group. See, the volume group is nothing, just either it's one physical volume or more than one physical volume. So collection of physical volumes become a volume group. Okay, and after that, from the volume group we can create partitions, like 29,932 partitions. Here, as I said here, from the volume group we can create till 29,932 partitions. Okay, see, if you look at the diagram, this is the physical disks. this physical disk slash dev slash sda slash dev slash sdb and is the c d e f g. These all are physical disks. Okay, these disks are these disks have been added to the virtual machine. Let's say just think and assume like that. Okay, so once the disks have been added to the virtual machines, this disk again converted to physical volume. So, for example, one disk size of the one disk would be around 500 GB or 1 TB or 500, 1500 GB like that. So there may be the size would be depends on the requirement, depends on the request. Okay, so the Linux admin team would make request to the VMware team to add the new disk. Okay, so when the request is made to the VMware team, the VMware team add the disk as per the request made by the OS admin. Okay, and after disk is added, the disk so this is the raw disk. This raw disk again converted to physical volume. This physical volume again collection of more than one physical volume, you know collection of more than one physical volume will be created as a volume group. So just physical volume group. So you can say the name explanatory, self-explanatory. The name itself is self-explanatory, so don't get confused. The volume group is grouping the volume. So collection of more than one physical volume. So so from this volume group we create a partitions. Okay, so you can create the partitions. 29,932 partitions can be created. This one. And volume groups, here I would say here volume groups are volume groups can be created up to 255. Okay, so from the volume group we create the partitions. From the physical volume, okay, this physical volume we create the volume group, and these physical volumes are converted as a physical volumes are converted from the physical disks. Okay, so this is the diagram. It's just hierarchical diagram. So there are around four layers. Okay, partition, LVM, and volume group, and physical volume, and physical disks. Only the thing that we have to deal with is three layers only. That is this one, this one. Until this, we have to deal with. Okay, so deal with this diagram. So physical volume and volume group and logical volume. So this is straightforward and clear and cut understanding of the diagram. I hope it's very helpful, this diagram. And let's go to the notepad and see. So I said volume disk is out of virtual machine. This disk is again convert to physical volume. Physical volume is again convert to volume group, and again logical volumes. So logical volumes. So how many volume groups? How many volume groups can be created? How many volume groups can be created? So this 255 VGs can be created. How many LVs can be created in a single disk? How many LVs can be created? 29,932 LVs. Okay, so this is about the disk architecture. Okay, from once the disk is added, so disk is converted to physical volume. More than one physical volume, volume group or volume groups are created by combining the more than one physical volumes. Okay, and from the volume group, LVs or partitions are created. So how many partitions can be created? 29,932 partitions. How many volume groups can be created? 255 volume groups can be created. Okay, so far so good. Next one is, so this is how we create the partitions, this pictorial wise. Okay, now see, so before that we need to know whether the disks are available in a system or not. So what is the command? What is the command to check if disks are available or not? So what is the command to check if the disks uh, lsblk? So lsblk command is used to see any free disks are available or not. Okay, so now we'll see what is the command to check. What is the command to check if PVs are exist or not? What is the command to check if PVs are exist or not? So PVs or PV display. PVs or PV display. PVs shows the physical volumes. PV display shows the complete information. Okay. Next one is, what's the command to check if VGs are exist or not? So VGs volume groups, VGs or VG display. VGs or VG display. This is a command. So to check if volume groups are exist or not. Okay. So what's the command to check if LVs are exist or not? LVs. What is the command? What is the command to check if LVs are exist or not? The command is LVs or LV display. Okay. So this is a, we can see, first we'll see practically. Okay. So first one is, let's see whether the disks are available or not. The command is lsblk. If you see here, uh, SDA, A is the disk, and under the SDA disk we have a partition SDA 1, 2, 3. So if you see here the type mount point, here it is written part. Okay, type is a part disk, and partition and LVM and disk, LVM disk and ROM. So if you see here lsblk, see lsblk is grep disk. See, if you see here we have a four disks currently in our system, SDA, B, E, F. So 100 GB, 50 GB, 16 GB, 20 GB. Now these two disks I have added right now, just now, 16 GB, 20 GB, SDE and SDF. So this is the command to see whether the disks are available or not. Okay, display for, see, if you see here, sorry. So if you see here, disk A, disk A partition, the total size 1 GB, 600 MB, and 81 GB, and C disk is 2.9 GB. So here, if you see here, the size, used space, available, and percentage on mounted, which directory the file is in existed. Okay, so this is how we can get the information regarding the disk and its size, used and available, and where it is mounted. Okay, so uh, to see physical volumes, the command is PVs. So PVs, we have two physical volumes. Okay, SDA3, SDB. These are the two physical volumes. Okay, so either you can use PVs or PV display. So PV display gives us the detailed information. This command, PV display command, gives us the detailed information like PV name, volume group, and PV size, and how much size is allocated, and total space and free space. So and UUID. So this is all information we can get by issuing the command PV display. Okay. Now we see how many volume groups we have. So to check how many volume groups in a system, the command is VGs. VG is only one, that is rel, and this VG is um, how many collection of no how many collection of PV the VG is made is two PVs. Okay, so from the two PVs the VG is created. I said earlier. So the VG is made up of more than one physical volumes. Okay, by combining more than two or three physical volumes, one volume group is created. Okay, and how many LVs? If you see here VGs, in VG we can come to know that VG name and how many PVs the VG is created, and how many LVs the VG has. Okay, so from the VG, LVs are created. Okay, so VG display. So command to see the volume groups in detail is the command is VG display. So name of the VG and uh, access and status, whether it's resizable or not, and it is read and write, and so open LV, maximum PV, and current PV, and VG size. Okay, and extend size, total physical extended size allocated. So these are information we can see. Okay, now we'll see how many LVs we have in a system. So LVs is home, root, swap. These all are, this home is to root, these all are from one VG. These three LVs are created from one VG. Okay, so rel we will see. So this so the commands to see PVs, VGs or LVs or PVs, PV display, LVs, LV display, VGs, VG display. So volume groups to know or physical volumes or partitions. The command is LVs like that. Next one is okay. So we have seen what are the commands to check the volume groups, physical volumes, logical volumes or partitions in system. So what are the steps that we need to follow to see or create the partition by using LVM method. So steps to create a partition using LVM method. So the first one is, before we start creating the partition using LVM method, Okay. First, we need to check or ensure that the disk is available in a system. Okay. If the disk is available, then only we can go ahead and create the partition. So until unless the disk is available, we can't do it. Therefore, first thing is we need to ensure that disk is available or not. How to check if the disk is available or not? By issuing the lsblk command. Okay. So by issuing the lsblk command, we can get to know we get to know that the disk is available. Once the disk is available, then we can convert the raw disk into physical volume. Okay. So before before start creating partition, ensure that disk is available in a system. If disk is if disk is not available, check with VMware team and get the disk to disk to get the disk to VM. Okay. So first thing is we have to verify the disk is available or not. So what is the command? lsblk. So uh, once the command is issued to verify the disk is available or not, okay, we have a disk. Okay, so after issuing the command, we can see that these so and so disks are available. So anyhow we have a disk, right? So I have added two disks. So once the disk is added, these disks are called as a raw disk. Okay, so this disk we will convert into. Second one is converting those converting the newly added disk into physical volumes. So we have to convert the newly added disks into physical volume. So how to create the physical volume? The command is pv create /dev /sde. If it is a one single disk, okay, if we have a more than one disk that are added to the virtual machine, then we can issue the command. See, if the one disk is added, then we can issue the command pv create /dev /sd. If we have more than one disk added to the virtual machine, then what is the command? Pv create /dev /sd e comma f. Okay, so if you see here, see lsblk flash grep disk. See, EAB is disk is added and used. Okay, the fresh and newly added disks are SDE, comma F. Okay, so these the two disks we can convert into physical volumes. Okay, so the command just now we have. Okay, first we will discuss. We will explain in a notepad. Then we will come and do practically. Okay, so PV create, if we have one disk, then we can use this. If we have more than one disk, we can issue the command in the same E comma F. Okay, again converting physical disks to volume group. So converting a physical disk to volume group. Here, what is the command? vg create slash vg create and name of the vg. Name of the vg app underscore vg slash dev slash ssd e comma f. So here, if you see here, so here we are creating a volume group. Okay, so we are creating a volume group by combining two disks. Okay, slash e comma f. We have two disks. I have added two disks, e comma f, to the virtual machine. So after adding the two disks, so I'm going to convert those two disks into physical volume. After converting the physical volume, I'm going to create one volume group. So I'm going to create one volume group by combining two disks. That is E, SD, E, SDF. Okay. So then from the volume group, okay, from the volume group, we can create one logical partition. Okay. So from volume group, logical partitions are created. So logical partitions are created from the volume group. So what is the command to create the a logical partition? lv create hyphen l. So here we have a we'll create 8g and hyphen n. So name of the lv db slash lv uh, db slash lv and the volume group app underscore vg. Now I app fb app. Okay, app volume group fb app lv. So here L is labeling size. Okay, hyphen capital L stands for labeling size. Capital L is labeling size, and small n is naming the LV. Okay, small. So labeling size L and naming the LV N. So if you see, if you look at the volume group creation, LV create, we give the command LV create. So when we create the PV create physical volume group and logical volume, the command is same like the PV create for physical volume creation. Volume group is VG create, and LV create for logical volume creation. Okay. So here we are giving the how much size for LV. capital L is for labeling the size, and the small n is to name the logical volume. So I am naming the logical volume as FB app underscore LV, and here under on which volume group, app VG volume group. So this volume group, under volume group, I'm creating the partition. Okay, so here we have created the partition. After creating the partition, we have to format the partition with any of the file system types. So we have file system types like ext2, ext3, ext4, and xfs. So with any of the file systems type, we can format the partition. Okay, so format the partition with any of the file system type. So file system type we have ext2, ext3, ext4, and xfs. XFS file system type. So we have, see, with any of the file system type, we can format the partition. Okay, so the next step is, after creating the partition, we have to format the partition. Since know what kind of the data, or what kind of the data that we are going to place in a partition, that is an important thing, which is why we we format the partition with a file system type. Okay, so what's the command? The command is mkfs dot. I want to format this partition with the xfs. xfs. Okay, and slash. We have to give here absolute path. Okay, slash div slash app underscore vg volume group slash fb app underscore lv. So here we have to give the absolute path slash div slash app vg and slash fb app lv. This is the lv partition. Okay, lv partition absolute path. And after, okay, we have formatted the partition with the file system. Now we create the mount point. Okay, we create the mount point and mount to that to particular mount point. So so creating the mount point, the next step is create a mount point on mount part partition to that mount point. So how to create the mount point? mkdir slash app data. App data is a mount point. Okay, and after creating the mount point, will mount. So what is the command to mount? Mount slash dev slash app underscore vg slash fb app underscore lv. This is the mount point. This is the absolute path under which mount point we are going to mount app underscore data. Okay, so uh, we have to create the mount point. After creating mount point, we have to mount that partition. Okay, the next one is, see here, though we have created the mount point and mounted the partition to the mount. Okay, but until and unless we mention or we specify this file system details in a slash etc slash fstab file, it will not be never permanent. I mean, the data, though the data is written, once the system is powered up, the data never going to be written permanently. So to make it permanent, we have to we have to make it a permanent mount point by mentioning this file system details, partition details in /etc/fstab file. Okay, so uh, uh, partition details should be updated in /etc/fstab file for permanent mount. Okay, so the partition details, so partition details should be updated in /etc/fstab file. Okay, for mounting permanently. Okay, for mounting it permanently, the partition details should be mentioned in /etc/fstab file. Okay, so how the first one is the device details. So device details should be mentioned. So complete absolute path. Okay, and first device name, absolute device path, and mount point app underscore data, and after that file system type. The file system type we use XFS, and permission permission details. So we are giving the permissions defaults, and backup checkup. Okay, so backup checkup we are giving the one. Okay, 0 is no backup checkup, and 1 is checking up the backup. And here again 2 is to check the file system checkup. So we have a here 1 is to backup checking, 2 is to file system checking. So file system we have a checking 0 1 2. 0 is no need to check, 1 is the first checking, 2 is last checking. So file system checking last, this is the 2 is to, that is the indication. Okay, number that signifies the whether to check the partitions, or to check the partitions first, or to check the partition last. 0 1 2. Okay, so this is the how the partitions are partitions are created using the LVM method. So these are the step by steps. Okay, I have mentioned I have detailed in Notepad. So we will see in a system, we will see in a operating system practically. Then only we can understand. Okay, so we'll see. Uh, so the new fresh disks that are added is SDE, SDF. Okay. Okay, now we have a two disk, that is raw disk. We have to convert this E, F disk into physical volume. Okay, so what's the command? PV create PV create /dev /sd E, F, because now we have two disks. So if we have one disk, then we no need to use the parenthesis. If we have a two disk, therefore I am using the parenthesis. So in one command we can convert two raw disk into physical volumes. Okay, PV create. Okay, so now here two disks are created. E, F physical volumes, two disks created. Now see, now let's create the volume group. So what I said is volume group is collection of one or more than one disks, one physical volumes. Okay, so by combining more than one physical volumes, volume group is created. So how to create the volume group? VG create. What is the VG name? Here we give here as per the notepad we have given. What is the app VG? app underscore vg slash dev slash ste comma f. So from we are creating the volume group, that is name, volume group name is app vg, by combining the two physical volumes, that is e comma f. Okay, e comma f, these volume groups we are combining, sorry, physical disk, that is physical volumes that are e comma f, we are combining to make it as a volume group, that is app vg. Okay, so it is okay, app vg already exists in a file system. Okay, let's create a different volume group, app vg db underscore vg slash dev slash st e comma f. Okay, see, volume group, this is successfully created. So from the volume group we can create partitions. Partitions nothing but logical volumes. Okay, so how to create the partitions? LV create. Okay, L L is labeling size. Okay, so I'm giving the 8 GB. Okay, now name of the logical volume. Name of the logical volume FB underscore data. So FB data, I'm giving the name. Okay, and under which LV, and sorry, under which volume group, that should be mentioned. So db underscore vg. Okay, so here the command is very important. LV create hyphen L, and how much size we are going to give to the LV, and hyphen N naming, hyphen capital L is stand for labeling size, hyphen N is to give the giving the name, okay, to the LV, that is name of the LV is FB underscore data. Next one is volume group. Volume group is DB database volume group. Okay, so once we click, if you see here, logical volume FB data is created. Okay, now we will format this LV with a file system type. Okay, so how the command is mkfs dot xfs slash devs slash db underscore vg underscore, sorry, so slash uh, fb underscore data. Okay, so we are formatting the file system completely. We should give the complete absolute path slash dev and volume group and name of the LV, logical partition, logical volume. Now if you see here, discarding blocks, and it is now it is partitioned, sorry, it is formatted with the file system. Okay, XFS. Now, so we have formatted the file system. Then the thing next one is we have to mount it to the mount point. So to mount it to the mount point, we have to create the mount point. How to create the mount point? mkdir slash slash data. Okay, we have created the mount point. Now we will mount it to we'll mount this partition to this mount point. Okay, so how to mount? we'll give the complete absolute path slash data. So we have to give the absolute path, complete path for mounting the partition into mount point. Okay. Now if you click, now it is mounted. Okay. But this is a temporary temporary mounting. So to make it a permanent mount, we have to update this partition details in slash etc slash fstab file. Okay. So so vi slash etc slash fstab slash etc slash fstab file. We have to update the partition details. So if you see here, we have so many partition details information here mentioned. Okay, so press the enter. Sorry, press the I letter I to insert the data. Now now I'm giving the complete path. Okay, so this is a complete path. Uh, this is a complete path should be given here. Okay, this is the device name slash dev slash db underscore vg fb underscore data is a absolute path that should be given. Okay, now we will give the volume group. Sorry, not volume group. Sorry, mount point. So where we have a mounted this one slash data, right? So we have to mention slash data. Now we have to mention the file system type. So I have used a file system type XFS, right? Sorry, XFS. Now the permissions you can use permission. I have used the permission defaults. Now I have used file system checkup one, sorry, backup checkup one and file system checkup two. Okay, so we have so this is the LV partition details should be updated in slash etc slash fstab file. Unless and until we update the partition details in fstab file, the partition will not be a permanent mount. Therefore, we should partition details should be updated in fstab file. Now let's save this. Now if you see here, it is mounted. Now uh, let's let's go to directory slash data. Now I'm in a slash directory pw p is the present work directory slash data. Now I can create files. I can create so I have created files and directories inside the mount point. So therefore, so I'm inside the mount point. So I have created one file and one directory. Okay. So if you see here, I have created one file and one folder. So to even if it is a permanent amount because it's permanent. So to make it a permanent, we have to update the partition details in slash etc fstab file. So this is how we can create the partition by using LVM method. So LVM partition, creating the partition using LVM method has a few advantages over basic method, because no basic method has certain constraints, like as I discussed initially in the class in the beginning I have discussed, right? So what are the constraints or limitations the basic method has over LVM? So we preferably choose the LVM method for disk partition. So as it gives us to create the partitions till 29,932 partitions, therefore we choose the uh, partition. We choose the LVM method for partition inside the disk. Okay. In the next class, we will see how to extend the partition and reduce the partition, because no, in LVM, which is the LVM is only used only for extending the disk or reducing the disk. That is the main intention behind the LVM. So to extend the disk or to reduce the disk, we use LVM, which is why we use the LVM over a basic method. In the next class, we are going to learn about disk extension or disk reduce. Okay, so I hope this this session is helpful and informative. And thank you for watching. And have a nice day. If you have any questions, queries, or anything you want me to cover the topics, please leave in the comments, and feel free to ask. Thank you for watching, and have a nice day. Bye.